In this, we are going to discuss about open 4G or 5G packet core. So we are starting with the core of the open. Now in this, the mobile core network which provides critical services like session management, packet forwarding, mobility management, authentication, policy control and enforcement, communication services, etc. These are all the services which are provided by the mobile core network. Outages of this, they have a very serious consequences because the large part of the network can go offline due to the core network fault. So in this, if the core network is at fault, there is a larger part that go to the offline mode. So we require to maintain the packet core very in a real time manner. Also, the various operators are at risk, and they are at risk when it comes to the core network. So if we talk about the progress on the virtual and the cloud native core, so mobile core applications, they are well suited to virtualization and also cloud infrastructure. So all the applications which are provided by the core network, they are very well suited to the virtualization and the cloud infrastructure. So in the control plane, the signaling and transaction workload which is involved in setting up, and also they are involved in managing the user sessions, they can readily processed on the general purpose CPUs. So in the user plane, mobile network traffic, which is lower than the fixed broadband networks, they can be handled on COTS servers. So we have two planes in the core network, control plane and the user plane. The control plane has signaling related functions and the user plane has all the data related functions. So all operators and vendors, they have worked. Why they have worked together? They have worked together basically so that they can virtualize the evolved packet core, IMS and policy infrastructure. So if we talk about the major challenges for this, or the major changes for the virtual evolved packet core and the mobile core, is that the multiple vendors, they require to rewrite their applications so that, and they have to rewrite the application so that they can run natively on a cloud infrastructure, and also support the associating scaling and resiliency models. So this is like how we can progress on a virtual and a cloud native core. So we have all operators, vendors, they are working together to virtualize the evolved packet core. The change is that the vendor, they have to rewrite their applications. Next is multi-vendor platform for evolved packet core. These 4G core virtual network functions, they should run on NFV infrastructure, and this infrastructure from different vendors, which means that Red Hat or OpenStack, VMware environments which are deployed on such hardware. Onboarding VNF, they has proven difficult, like how they can scale them, how they can ensure the performance and managing the life cycle, they have proven even more difficult for this. So many of these deployments today, they are effectively full stack NFV, and also they have a lead vendor which provide these functions, middleware and integration services. So if we talk about system integration for the cloud based mobile core, so we have a design, project scope and building and testing. Under the design, we have hardware infrastructure, overlay, open stack infrastructure, generic virtual network functions and security. There is a test and integration, automation is also there, and NFVO or VNFM. Under the project scope, we have design and documentation, configuration, integration and testing, acceptance testing, operational readiness and handover, POCs and onboarding support. For build and testing, we have integration testing, regression testing, automation, acceptance testing, first level and second level support and POC support. This is about our core, open 4G and 5G core that we have discussed in this. Thank you.